1B, right?
Yep.
Forecaster needs and activities supporting operations. We have 3 talks, and then we're going to wrap up this section with an open discussion on R2O, the nexus to R2O that Wallace will be moderating. But our first talk is NSC Season Summary Analysis and Verification by John Cangliolosi.
I can't say still. Hey, good afternoon, everybody. Before we start, I want to thank John Martinez over there. He basically did all of this. I'm just standing up here speaking about it. So thank you, John. It's delegation, Frank. I'm learning. Thank you, John. We really appreciate it. All right, if you go to the next slide, Mike kind of talked about this a little bit, but I want to show, there we go. I want to show some of the mean statistics from NHC, and he did speak about this, but we're going to kind of spell it out a little bit more here. So first, take a look at the graph there on the left, and I want you to focus on the blue line. That is NHC's mean error from the Atlantic Basin in 2024. And if you just look at it, you'll be like, well, yeah, it goes up with forecast time like it does every year. But what's different in 2024 compared to normal is the rate at which the error actually went up over the forecast time. Typically, it goes up by about 30 to 35 nautical miles per day, but in 2024, look at the track error column there on the right in the table. The day 1 error was 20 nautical miles. The day 5 error was 115 nautical miles. You'll see every number shaded in green. Those are records, as Mike said, for the lowest errors we've had in history. I'll kind of repeat, NHC has never been this good in our history. What do you think? Round of applause? Yeah, come on. That's Philippe. That's for you, Philippe, new senior hurricane specialist there. All right, we'll talk more about the track errors in the context of those coming up, but take a look at the intensity errors first. That's the green line. Notice that it goes up pretty steadily for about 3 or 4 days and then flattens out. Now, if you look at the mean intensity errors in the table on the right, nothing there is shaded in green, so no records. But if you look at the mean values themselves, they're pretty low. 12 knots, 13 knots, 13 knots. These are pretty close to NHC's average, but I'll talk why I think this is a win coming up in just a little bit. All right, so go to the next slide. And we've all seen this, so let's put this into context with history here a little bit. And first, zoom over to the right. Day 1 error is shown in red. Day 5 error is shown in blue. This is all from NHC going back to 1990. You'll notice 2024 dropped off the local highs we had last year. Again, the lowest they've been in history in every single forecast interval. And if you zoom out and look at the trends going back to 1990, you'll notice the trends are impressive. The errors today are about 75% smaller than they were in 1990 at just about every single forecast interval that was available back in 1990. Now, I know what some of the critics would say, and I'm frank, when I put this together, I instantly thought of James, because I do call him a critic, even though he worked at NHC. And he would say, well, that's in error space. Every sample is different. And you can't just say you did great because maybe you had an easy set of storms. So if you go one more slide, let's take a look at it in skill space, which kind of gets at that problem, and it looks against climatology and persistence. And if you look in 2024, he'd have a point. We're not at necessarily records at every single time, but we're at the upper end of the channel, the high channel that we've been in since about 2017. So a very good performance. And if you look at a longer term period, you'll see how much skill has grown. I mean, back in the 90s, skill was around 20% on average over Clipper. And then back in the 2000s, they were around 50%. And today we're about 75% over Clipper. So lots of improvement, but again, not record breaking from a skill perspective. All right, if you go another slide, let's talk about the characters of the season. And I heard someone brought up earlier that the season's been hyperactive. And yeah, I'm pretty exhausted, I got to be honest. And I don't think anyone is dreading this Caribbean system more than NHC. I'll be honest. At least I am, because I'm going to work midnights for every single one of them, and I'm staring at them. So I'm already depressed. But if we look at how many forecasts that we issued so far in 2024, excluding what's coming, it was 333. That's not that big. The mean going back to 1990, if you just kind of take an average of all of this, it's 325. So if we didn't get another storm, it would look kind of forgettable on this graph overall, actually lower than last year, and way off the peaks of 2020 and 2005, for example. But it shows how this statistic doesn't talk about any consequences. It's simply how many forecasts that we've issued. All right, if you go another slide, let's talk about which models work best in 2024. So again, we're in skill space. So the higher the line, the more skillful the prediction. NHC's in black, up at the high end of the overall model suite here. And in fact, we beat all of the models at a few forecast time periods and then kind of battled it out with HICA and TVCA, the best performing aids, the consensus aids. So that's kind of the way it is sort of every year. But let's talk about which models specifically work best, which individual models work best. So for first place in track, it's split. The European Center, which is in light blue, you'll have to squint to see it. It has about 5% less skill than the consensus aids, and the Hurricane Center forecast was best from 12 to 72 hours. But GFS was best at 96 and 120 hours. And for the relatively small sample of 50 here, GFS beat the Hurricane Center, by the way. All right, now I know we're very interested in the hurricane regional models here, and I really can't give a winner for that suite. They're kind of zigzagging across each other here. So HWRF, HMON, HAFS A, HAFS B, they're all kind of in the mix. And what's different in 2024 is there's no real laggards. You know, sometimes we see a model that just kind of stunk it up. We don't really have that in the Atlantic. The bottom end of the pack is pretty close to the middle of the pack is what I'm trying to say. The Canadian and the UK Met are the ones at the bottom, but I really wouldn't call them major laggards here. All right, if we go to the next slide, let's talk about intensity in the Atlantic. I'm actually really fascinated with some of the statistics, and I hope you are too. So we're going to spend a little time here. So the black lines first represent the Hurricane Center's errors. The solid one is from 2024. The dashed one is NHC's previous 5-year mean from 2019 to 2023. And you'll notice the 2024 errors are basically near the mean or maybe just a tick above the mean. You might say that's not that great. But compare that against decay Schiffer, or the equivalent of climatology and persistence there. Notice that its 2024 errors, the solid red line, is well above its 5-year mean, which implies that this was a very challenging set of storms that we had in 2024 to predict intensity, and it felt that way. It definitely felt that way, and for good reason. We had 34 cases of rapid intensification. If that sounds like a big number, it is. Going back over the past 10 years, the mean's about 18. So this was a very challenging set of storms. And if you go to the next slide, I want to take a sidestep for a second. I want to only look at storms that rapidly intensified and kind of see how we're progressing at NHC for just this subset of storms. Now, we can't do that on an annual basis. The data is too noisy. We got to really lump in years and get a lot of cases together. So if we go back and go from 2009 to 2013, that's this first green bar here, and look at the 24-hour forecast bias from NHC for that group of storms, it was about 26 knots too low. That's pretty bad. In 2014 to 2018, it was about 21 knots too low. And from 2019 to 2023, it was about 11 knots too low. Check out the progress here. We're getting closer to the zero line. Now, I've been at NHC this entire graph. In fact, I have been in HSU operations this entire graph. So I feel very qualified to make this statement. You may or may not agree. When I was a forecaster in 2009 and 2010, and the HWRF predicted rapid intensification, I mostly laughed at it. I never would have used it. That is not the case today. When the HAFS, the HWRF, or the HMON shows something like that, it gets our attention. And I was particularly impressed with the HAFS performance structurally, like you said, Gus, in the eyewall replacement cycles, in the deepening pressure, in the compact structure. So these models have come a long way. And although I would love NHC to just take this credit, the credit here belongs to this community for advancing the models. The credit here is notable. This isn't victory, but this is significant progress. All right, let's go to another slide and kind of move away. Oh, slide forward. And if we, sorry, that's okay. And if we move away, just talk about intensity error trends in general. Day 1 error again in red, day 5 error in blue. It's noisy. Lots of year-to-year variability. If we go to the right and look at 2024, it kind of ticked up a little bit off the local lows in 2022 and 2023. But if you zoom out and look at the trends, you'll notice that we're making progress. Yeah, it's noisy. but there's slow and steady progress with slowly dropping errors over time.
5 minutes.
Okay, if you go another slide, let's look at it in skill space. It's a little cleaner. And you can see here, skills gradually climbing from an intensity perspective. In the 90s, skill was zigzagging around the 0 line. In the 2000s, it was about 15 or 20%. And today's skills roughly 45% over decay shifter. So clearly progress here as in terms of the intensity parameter in general. All right, if you go another slide, let's talk about which models work best as we move forward. This is 2024 specifically. And you can see skill kind of peaks out around 45 or 50% amongst the Hurricane Center and some of the best models. NHC is up at the top, actually better than all of the models in the short term at 12 and 24 hours, and then close to the best performing models, again, HICA and IVCN here. But amongst the best individual models, it was the Hurricane regional models, but amongst that group, HMON was the winner. And I say this every year, sometimes it pays to do a little less. It was the best individual model from this vantage point. If we need to do a structure analysis, I got to imagine that would go to HAFS. But amongst the intensity parameter itself, HMON was the winner. It's that orange line that I highlighted. HAFS A, HAFS B, HWRF were a little less good. SHIPS and LGEM still have the utility. They still have utility, Mark. I mean, in fact, they beat some of the models at the extended. And notice that the globals, GFS, is working its way north into the pack, beginning to get competitive with the Hurricane regional models. The Euro's lagging it a little bit. All right, if you go further, we'll just talk again briefly about rapid intensification. Now, I don't have a lot of time here, but what I want to point out is this is not exactly an RI verification. This is kind of a near RI verification. It's 25 knots over 24 hours. The RI cases were 34, but the non-RI or near RI cases were 175. And if you look at this diagram and just see where NHC falls right here, the black dot, you'll notice that it has the highest probability of detection, the lowest bias along the diagonal, and the most skillful forecast measured by this index more than the available models. All right, if we go forward, briefly just want to touch on the EastPack. So no records here at all. Track forecasts look about average. Intensity forecasts look pretty bad. We're going to have to dig into this. I didn't have time to even think about the EastPack, but intensity errors of 20, 21 knots is not too good at day 4 and day 5. So we'll have to dig into that and give it a little attention. If we go forward, I'm not sure, did anyone actually pay attention to these specific this year at all? Nobody's even raising their hands. All right, Stan is the only one in the room, apparently. It was dead. The EastPack was dead. I don't think there's another word to call it. We had just under 200 forecasts in that basin. If that number sounds low, it is well below the average of about 330 going back to 1990. A really, really quiet year overall. So I'm not super worried about the sample at the extended because there just isn't that many forecasts. You go forward, I just want to show a couple quick stats in the East Pacific. This is the track verification for that basin. NHC is up at top, but we were beat by one model at every single forecast time in the East Pacific. And that was the Florida State Super Ensemble. At least that university got something right this year. I'll just leave that there. Best models here individually was the same as the Atlantic, split between the Euro and the short terms from 12 to 60 hours, and GFS at the longer leads from 72 to 120. Amongst the Hurricane regional models, HAFS B1 in this basin. For track, it's this light green line that's kind of buried in here. And unlike the Atlantic, there were notable laggards this time. The UK Met that's in pink and the Canadian that's in yellow were notably outside of the pack for track prediction. I think I got one or two more slides here. Here's intensity results in the East Pacific. So again, the Hurricane Center forecast, not as good as the consensus aids in this basin. You can see we were beat by most times. Hurricane Center is the black line. Best individual model also goes to the HMON in the East Pacific. In fact, it stands alone above the consensus models at 96 and 120 hours. HAFS B was probably second place. GFS is competitive in both basins. It's this dark blue line. Euro, not so much, kind of zigzagging around the 0 line. And LGEM was kind of the loser here. No skill at 96 and 120 hours. Again, for a relatively small sample. All right, last slide. Just want to briefly point out some of the main statistic results. Record-breaking year for the track in the Atlantic, really great from NHC this year. Best track model, again, is a split between the Euro and GFS for the different lead times. HMON, the clear winner for intensity in the Atlantic. And HAFS, They're middle of the road for the track and intensity statistics, but they feel better than that, if that means anything, by looking at them in operations. All right, and these specific, just go forward one. There we go. So no records there. We got to dig into the intensity areas. Again, same results. Euro GFS split for best track. HMON wins again for intensity, and HAFS pretty good in the East Pack. That's all I got.
And we're good. That's the end of our time.
All right. Well, thank you, John. In the interest of time, we're gonna move to the next talk. We have, plenty of time for discussion later in this session. So the next talk is by Mark Klein from the Weather Prediction Center on WPC rainfall and flooding forecasting.
Give me 1 second here.
Pablo, am I gonna run the slides or are you running them over there?
Aaron is gonna, right? You're gonna run that?
Mark, if you want to share and run it, that's fine.
Okay.
Whatever's easier for you.
You can do it if you're there.
Yeah, I can load it. Give me a second.
While we're starting, we can start anyway. The first slide is just my name. So I'm Mark Klein. I'm the Science and Operations Officer at the Weather Prediction Center. And today I will be talking about WPC's QPF products, our role in the tropical program, and then a little bit of verification. And I should have talked a little longer.
Yeah, sorry. Got to remember which screen I'm on here.
Oh, that's good. Okay. So you can now go to slide 2 once you've started.
Yep. Just need to get the slideshow full screen here.
All right. So just want to give a brief overview of WPC, the high level overview. We do, for those of you who may not know us as well, we do a multitude of different forecasts for the CONUS. We have OCONUS responsibilities. We've got an international desk we've had for a couple decades. It trains forecasters from Central and South America and the Caribbean islands and produces IDSS, and that's something I'll talk about a little bit later. But the real focus, in terms of the tropical program is in that red area. We coordinate rainfall statements, both with NHC and CPHC, and produce rainfall graphics for systems hitting the CONUS, as well as excessive rainfall or flash flood graphics for the CONUS out to day 5. So you can go to the next slide. It's just as a review of WPC's QPF products, basically. The 4 on the left, the 4 on the left, the top 4 on the left, I'm sorry, are all based off of WPC's official QPF. The lower 2 on the left-hand side are probabilistic forecasting for flash flooding, and then the final one is an IDSS type forecast. So starting with the top layer there, QPF, which has been our go-to product since 1960. We produce that forecast out to day 7. Then when there is a tropical system that's affecting the CONUS, for the NHC's website and WPC's, we produce the Zoom tropical cyclone graphic that may go out to day 5, typically not much more than that in terms of the forecast. In the day 1 to 3 period, we've got probabilistic QPF, so probability of exceeding certain amounts, potential for worst case scenarios. And then also the extreme precip monitor, which essentially is comparing our QPF and PQPF to average occurrence intervals. So just getting a sense of what the 50, 100-year, 500-year rainfall event. Then below that is the excessive rainfall. Look, this is typically, you can look at it as a proxy for potential for flash flooding within 25 miles of a point. We currently produce this forecast out to day 5, but we are looking to extend this out into the day 7 period. And finally, our shortest term product is the mesoscale precipitation discussion. This is focused really on the 0 to 12 hour forecast and really tries to highlight, at least in the really short term, where is the heaviest rain going to fall with the tropical system or with any of our heavy rainfall events. So going to the next slide. So where do we fit here in the tropical program? We coordinate the rainfall statements with our international desk, if it's OCONUS, and with our other forecasters for the public advisories and key messages. And then, as I showed before, we have the zoomed rainfall forecast available from the site, and also a flash flood potential, which can be sometimes a day 1 to 3 or 1 to 5 compilation. Going on to the next slide. So I did talk about the international desks and their training focus. The international desks have really grown. They've been around for a couple of decades, but we've increased our number of forecasters up to 5 now, and they produce a lot more IDSS for rainfall events across the tropics. But starting this year in particular, their QPF graphics have been added to NHC's website when there is a system affecting the Oconus. So that's a big change, but they do support a huge number of partners throughout the year. Let's go to the next slide. So, turning a little bit to the meteorology, you might have remembered this slide. It was probably there last year, but it rains with every tropical system. There's nothing that it's surprising about that, but it really is the question: how do you differentiate between the storms that don't produce really anything more than garden variety or maybe some very localized heavy rains to the most impactful, the very few that have widespread catastrophic rainfall? These are obviously the ones that we need to provide the most lead time for, and provide the best messaging, and also the least number of false alarms. We don't want to call everything catastrophic. But unfortunately this year, as Mike had pointed out in his talk, we did have that kind of event with Helene. And so I want to kind of go into some of our products and IDSS for that in the next couple slides. So next slide, there we go. So this is just looking at a visual verification of our 24-hour rainfall during landfall. So it's between 12Z the 26th and 12Z the 27th. This was a tough forecast, and I know I was watching this many, many days in advance because I have family in Tampa. And so I was just trying to, watch the system. But basically, this was a hard forecast, partly because the time from formation to landfall was basically like 3.5 to 4 days. So on day 6, we kind of knew there was going to be a tropical system of some sort, but there was no consensus at all. There was a lot of spread in the tracks. So you can see we really didn't have a lot of QPF into the CONUS at all. We started finally getting, a little bit more of consensus on day 5, and had a significant increase in the precipitation in that forecast. And that is actually unusual for us to have that much of a change from day to day in terms of QPF. But then as the storm formed and we got the really tight track guidance, our forecasts ramped up significantly for the day 4 period. And then finally we hit the highlights on day 3 with the heaviest rainfall coming inland across the Panhandle, and then also across the southern and south central Appalachians. So, of course, prior to this was the predecessor rainfall event. So this was just, all of this rainfall was exacerbated essentially because it was a two-day very heavy rainfall event. So going on to the next slide, this is really just, it's a busy slide, but it kind of looks at our IDSS for, focusing in on one county, which had some of the worst flooding and fatalities. So basically going from left to right here is just kind of a timeline of our products and how our products evolved and changed over the course of the forecasts. So starting out at the day 4 and the day 5 period, we were getting the word out on social media that there was going to be a heavy event. Our excessive rainfall outlooks started ramping up a little bit, with forecasts not really significant at this point, but slight areas in our day 4 and 5 are actually a little bit unusual. So we were hitting that. Then as we got into the day 3 period, we started definitely seeing the tightening of the guidance with the track and also the QPF. So our excessive rainfall outlook, we raised the risk level to moderate. And then finally, toward the end of day 2, we raised it to high across the southern Appalachians. And high risks really do mean a lot. We've done some studies. that when we have 40% of all flash flood related fatalities occur in our high risk areas, and 80% of flood related damage occurs in the high risk areas. So it's a big deal when we put a high risk area, and it's pretty rare. We gradually upped the wording as we got into the later part of the day, kind of late day 2. This was when it was, upping to the potential for catastrophic event. And then finally, on the far right there, this is when our shorter term mesoscale precipitation discussions will come into play. And we issued quite a few of those, several of them ahead of the flash flood emergencies that were issued. So this was, again, trying to highlight where that heaviest rain would fall in the very short term. Okay, the next slide. So just a summary of the IDSS activities for WPC. We led a number of hydro coordination calls with the National Water Center, with FEMA. We had 24 collaboration calls related to QPF and flash flooding with WFOs, the RFCs, and the regional operations centers, and then a slew of media interviews associated with the rainfall impacts. So going to the next slide, I want to talk a little bit about verification. I think this is something that's been shown previously, but similar to looking at the NHC track errors, one way it's a neat way of looking at QPF verification is essentially tracking the displacement error between, and in this case, what we're using is a mode code from DTC, and basically tracking or calculating the distance between the centroids of the observed precip and the forecast precipitation. So we've been doing this for quite a few years. And then if you go to the next slide, this is looking at our, from the 2016 to 2023 period, all the tropical cyclones. We're looking at a 2-inch rainfall contour. And just here's the average error in terms of the displacement, ranges from about 50 miles at day 2 to 100 miles at day 3, or day 1, 100 miles at day 3, and then about 150 miles at day 5. We picked 2 inches because it had a reasonable number of cases to be able to focus on. If we picked more than that, we wouldn't have as many cases. And less than that really isn't necessarily a significantly impactful event. So just to visualize this is a forecast we had for Sally. The heaviest rain was forecast at this time over the southern Mississippi and Alabama, but looking at our overall potential for errors within 100 miles, it could end up anywhere within that dashed line. And in fact, the heaviest rain did occur in the Western Florida Panhandle. Going to the next slide.
2 minutes.
Along with the magnitude of displacement errors, we look at the directional errors as well as for the QPF. And this is looking at a higher threshold and looking at days 1 through 4. So these Windrose plots are showing, very consistently throughout the forecast that there's a displacement to the northeast. So what this is essentially meaning is that the observed precipitation centroid, the center of the observed precip, is northeast of the center of where WPC's QPF is. So this could mean one of probably 2 things. One is the tracks happen to be a little bit slow. Or it could be that the model forecasts are not hitting the northeastern quadrants of storms with as much QPF as is needed. I probably think it's more likely to be the slow storm situation, but again, we really haven't looked too deeply into the reasons. So let's go on to the next slide. I did want to show some HAFS output. We do get this at WPC and haven't looked at it as much as we probably could, but I think the main takeaway here is for both HAFS A and B, it's really good guidance, and it's something to not, as we talked about before, we don't want to, just focus on winds with these systems, but it's really important to keep focusing and improving the QPF. But in general, this is just looking at the day 2 forecast for the pre-event on the left-hand side compared to the observed stage 4 and at the bottom. And it pretty much nailed the area. It was maybe a little bit off, and actually its amounts were a little bit too heavy. But then the main day of the event is on the right-hand side, day 2 forecasts, and excellent footprint forecast, got some of the heaviest amounts in the correct regions. So it did provide some very quality guidance. I think the only odd thing was, at least in this track, there was a very strange line of very heavy precipitation right along the track of the center that didn't verify. So that might be something to look into. And then the next slide just kind of goes into...
Let's wrap it up on this one, all right?
Okay, this is the last one. So what are our greatest needs? Improvements to the track forecast probably is, but of course you guys had error, the lowest errors this year, so can't ask for too much more. Understanding the high-res models, the hurricane models, and their biases and their performance with respect to rainfall. So maybe putting together some kind of WPC NHC workshop. Where does the national blend fit in? There's going to be feature matching tools added to version 4.3. That'll help with the winds, but how will that won't really help with the QPF. Continued improvement of probabilistic information that's rooted specifically in thresholds that are impactful, like rainfall exceeding flash flood guidance, or exceeding average occurrence intervals. And then things that are HAFS related, being able to get it into AWIPS easily. We've had some trouble with some of the hurricane models because the amount of data is so huge. Access, we might have access to the ensembles in some way, but I don't know how, and I'd really like to get to know that. And then just, going in with the concept of let's actually get some robust verification of the QPF to see how it's really doing objectively. And that's it.
All right, thanks, Mark. Let's hang up to any question we might have. We have, a discussion session at the end here. All right, the next talk is from Levi from JTWC forecast challenges. So you can. Is the other microphone?
Right here. I think there's the boom mic there.
Okay. You can use that or that?
I'll use this. That's good.
If
If this works, that's good. All right. Hi. Thank you, everybody. Good to be here again. I'm Levi Cowan. I'm from the Joint Typhoon Warning Center, which, if anyone isn't aware, is the Tropical Cyclone Forecasting Authority for the Department of Defense in the Indian Ocean, Western Pacific, and South Pacific. And we provide the TC forecast guidance for the National Weather Service in Guam and American Samoa. Next slide. I'm just going to talk a little bit about kind of our overall 2024 year-to-date TC forecast performance and a couple of the interesting cases that I picked out that kind of highlight some of the challenges that still exist in operational forecasting in our area of responsibility. This is the overall error graph, similar to what John was showing just a couple of talks ago for NHC. On the left is track, on the right is intensity. For track, you can see the overall channel downward in average error, has continued, similar to, the other forecasting agencies. Quite a significant tick up, especially at longer lead times, though, this year. So whatever happened to NHC last year, I think it might have rubbed off on us. So thanks for that. Hopefully we come right back down like you guys did this year, next year. Not entirely sure yet how to diagnose that kind of systematic uptick, but I do know there were a couple of big squirrely outlier cases similar to Philippe from last year that contributed to NHC's season averaged error. For intensity, a little bit more of a mixed bag. We had a tick up in the errors at longer leads, but a tick downward at shorter leads. Again, a little difficult to explain there, but within the overall downward channel in error reduction that we've seen over the last 20 years. Next slide. This is how we did versus some of the models that we use in our typical consensus for track on the left, intensity on the right. In terms of HAFS relative to the rest of the suite, in Trackland, it was kind of near the worst end of the individual models, with HWC and the multi-model consensus being the best members here, and HAFS kind of up there, still better than NavGem, which is not that hard to do, but within the kind of worst grouping there in terms of track at most lead times. For intensity, HAFS is actually one of the better individual models out through 72 hours. And then in this particular sample, it gets worse at days 4 and 5, but certainly less sample count there, getting down to 100 or less for this one season. And JTWC official forecast is the best here, including beating the multi-model consensus, which we've done a couple of years in a row, which is nice to see. Next slide, please. Hopefully, if you go next again, there's a video. Okay, good. Maybe one more to play it. No, that's the next one. Maybe the last one won't play. But this is Typhoon 23 Whiskey. This is Kong Ray. This was a really large typhoon that developed in the Philippine Sea not that long ago. This is a pretty recent case. And I found this fascinating because it was one of those really large scale, almost synoptic scale tropical cyclones that slowly consolidated over a period of several days. And it was well modeled in the sense that, you know, large TCs, you typically get a really good signal at pretty long lead times, but the ultimate consolidation of the inner core structure was what really mattered for this one. And so it actually became one of our challenging cases just a few weeks ago. So if we go one slide forward, this was the culmination at peak intensity. And this is a great loop provided by CIRA showing the intense mixing. You can see all the Rossby wave activity within this very large eye. It's about 60 nautical miles across at peak intensity. And this is just a beautiful case of a large inner core that was extremely intense. This may have peaked at 130 to 145 knots. We won't know for sure until we do the post-analysis on this, but very, very intense super typhoon. And this posed some challenges actually for modeling. If you go forward one more. This GIF here is showing all of the HAFS-A 10-meter wind field forecasts valid from lead times of 0 up to 120 hours. So 5 days worth of forecasts. And at the end there, you'll see the dark pinks show up where the verification is closer to the real intensity of 130 plus knots right there. But until those final forecasts, there was quite a variability here of eye sizes and the intensity of the inner wind ring associated with this storm. And while HAFS got the overall picture relatively correct of a large typhoon with a large inner core, it had a problem getting the peak intensity, as did most modeling for that matter, and the official forecast all struggled to capture the super typhoon levels of wind that ended up occurring in this eye wall. So it just seems like with, you know, all of the mixing processes going on, this was all before an eye wall replacement that ultimately happened after the peak intensity, but getting the radial distribution of momentum correct seemed to be quite challenging even for our high resolution modeling. And of course, the age-old question, you know, what kind of DA or physics problems could be at play here? Maybe a mix of both, difficult to say without a study. Next slide, please. This is just an example, time series plot of the best track in black, the intensity peaking here, 130 knots, could have been as high as 145. We'll see once we do the post-analysis later this year or next. The green lines show the different HAFS-A intensity forecasts, which, along with most other models, which I haven't bothered showing here, peaked 35 or even 40 knots too low in the 2 to 4 day lead times here. And again, the overall forecast not really that bad. The forecast for a large chord typhoon at high intensities above 100 knots in the Philippine Sea verified quite well, but the details of the inner core still a challenge here. Next slide. And funny enough, this case also reminded us that big track busts can still happen. And even for a large typhoon, I noted that, you know, the larger storms, they're kind of more synoptic in scale, and models tend to give us really good signals on these long in advance. But in this case, the track was a classic, what we call a fishboning case, where it continually walked westward over time. That graph on the right shows all the consensus track forecasts, and of course, the official JTWC forecast was close to those. Kept walking from east of the Japanese Ryukyu Islands west and west and west until it finally ended up in Taiwan, which is where the final landfall occurred. The GIF on the left there shows the 500 millibar height and anomaly from the GFS for lead times up to 132 hours, so 5.5 days, showing that typhoon in, you know, roughly a similar spot east of Luzon, southeast of Taiwan. But if you look at the Ryukyu Islands, there's a ridge to the northeast of the storm that just was forecast too weak systematically by almost every model I looked at. It wasn't just GFS, I'm not picking on it here, but all models, including, by the way, the data-driven AI models, were systematically too weak with this particular ridge right up until the end. And so it really wasn't until the final 48 hours when we kind of locked in on that ultimate trajectory across Taiwan. So this was an interesting case where even track was highly adjusting right up until the end. Next slide. One more case I want to share here is 14 whiskey. This was Bebinka. And this was a case, you can see from the satellite animation, again, courtesy of Sierra here. I stole a lot of their stuff for this talk. But the Sierra's cloud motions you can see on the left-hand side of that plot show a big upper level low to the west of the tropical cyclone, which is developing in the center of the image with some sporadic deep convection over the center. This was a case where the TC was pivoting counterclockwise around the upper level low, and there was moderate to strong southerly shear over the system initially and some dry air up shear. And that kept us pretty weak, around 30 knots for a good while, for a couple of days. And the forecast here said that this was going to pivot around the upper level low, shear was going to come down to more moderate levels, and the core was going to be able to symmetrize markedly and cause a rapid intensification event. And so models were initially very aggressive on this particular system in the 48 hours that precede this animation. So if we go forward one slide. This is a representation of what the COAMPS TC ensemble mean showed in terms of radar reflectivity. So this is the average from the ensemble. The upper plot there is for the 48-hour forecast from NRL. They made these graphics, which is really nice. And you can see that this is how the asymmetry was given the southerly shear according to the upper level low to the west, and how that verified versus the AMSR2 microwave pass at 89 gigahertz on the right. And you can see it, it got that structure relatively correct. And that's what happened in reality. But what all models, not just COAMPS TC, again, not trying to pick on it, but what most models showed was when you go to the bottom panel, it expected a rapid symmetrization of the convection around the inner core and tremendous deepening. So we had rapid intensification almost unanimously forecast by our intensity model guidance suite. If you look at the AMSR2 image, though, you'll see that while convection did rotate around and is now concentrated in the southeastern quadrant of the storm circulation, it's not really a complete eye wall or anything, symmetric and strong. There was still going on here, although the shear had come down, there was dry air issues getting mixed into the inner core in a way that models just could not capture. They over-generated convection in a systematic sense and did not understand that a complete inner core would take longer to form. So forward one more. This was an example of some of the intensity forecast guidance from HAFS, COAMPS TC, and JHWC. And I apologize that this plot is not the prettiest one you're going to see today, but I had limited time to make this talk. The HAFS is in green, the official forecast is in red, and COAMPS TC is in pink. And what you'll see here is that the best track in black verified at about 75 knots peak at the time of that latter AMSR2 image. And most modeling and the official forecast were at least 35 to 40 knots too high in a lot of these cases. COAMPS TC actually struggled more here, with some of these reaching category 5 equivalent intensity at that verifying time. HAFS did pick up on reality a little bit sooner. So once we got to lead times within 48 hours, it had corrected down. So you'll see a group of those members down below 75 knots. Some of them actually verified a little too low, but they did catch on to the struggles that the vortex was having earlier than COAMPS, and the official forecast also corrected at that time, but we have some high errors in there contributing from this case. So this just goes to show that interaction with moderate shear, we've talked about this ad nauseum as a community, continue to be a struggle, especially when there's environmental dry air and limited in situ observations to sample. Satellites do a great job for us, but I suspect if we had maybe a little more sampling with dropsondes or something in the Western Pacific, we might be able to catch cases like this a little bit earlier. Next slide. Yeah, I think this is it here for this talk. Just in summary, our preliminary forecast error, which is not finalized yet, but just year-to-date preliminary, ticked up overall in 2024. Might have had a few more difficult cases this year anecdotally than last year, a few more squirrely cases. But in general, the season continued to provide anecdotes that, some of these moderate shear with dry air on the upshear side cases, along with more exotic core wind field structures. Those are kind of areas where we see some challenges, even for the great models that we now have. And I do want to say thank you. DoD and JHWC rely a lot on the work that's done by this community here. I've been a part of it for a long time, and we really benefit from models like HAFS and GFS and the work that you guys are doing. So thank you very much.
All right. Well, thank you. Everybody, let's hold on to any questions, and we're running a couple of minutes behind, but we make sure, Wallace and I will make sure that as we go into the discussion phase here after Wallace talk, then any question you might have for the previous speaker, feel free to do so. So I just realized that we started this session. I would imagine a good chunk of you, if not most, know who I am, but just in case you don't, I'm Pablo Santos. I'm the chief of the Technology and Science branch at the Hurricane Center. And the next talk is an idea that Wallace, our Science and Operation Officer, Wallace, why don't you move over here? We had an idea, we wanted to talk with the community. We taught this R2O Nexus discussion. It's a discussion preamble by a few slides that Wallace has to share with all of you. The R2O Nexus discussion and NHC perspective. I just wanted to, for a minute or so, I've been in this job for a year and a half. And I have some numbers to share with you after Wallace talk here. But what astonishes me is the amount of work is being done in the research area and the fraction of those that actually end up in front of the forecaster. And that's, in my view, that's a problem. And we need to have an open conversation with the research community about how we change that going forward. And because it's paramount. We are moving into an era of increasing oversight. We have to justify really well how our funds are being used. And we have plenty of justification. But are we being the most efficient in the execution of those funds and the end result? If it doesn't end in the front of the forecasters, enhancing their analysis capabilities, prognostic capabilities, the decision support services that they provide, going back to all those comments that the opening speakers made earlier, then is that an efficient good use of our taxpayer dollar, the taxpayer dollars? I think that is a really important discussion we need to have. And with that said, I'm just going to go ahead and pass it on to Wallace, who's going to go through that right here.
All right, thanks, Pablo. So it's getting late. So I hope this session is going to be a fun one. I'm not going to talk too much. Give me 5 minutes to set this up, and I'm hoping we can spend the rest 45 minutes discussing some potentially tough issues. Gus said he's not going to be provocative. I'm going to try and be a little bit provocative. So the challenge here, research to operations. So we've heard a lot about the forecast challenges from the previous speakers. Getting new things into operations is tough. It's messy, and I would argue it's suboptimal right now. But in terms of the opportunity, look around the room. If anybody is going to solve a hurricane-related problem, they're sitting in the room here or in the online chat room. So today, through this discussion, I'm hoping we can identify some ways, not necessarily to get things into operations at the Hurricane Center or on WCOS, but maximize the impact we have through the work we're doing. All right, next slide. Okay, I've used this image before. This is often how we talk about R2O. It's a beautiful, shiny diagram. The funnel tapers perfectly down to operations and impact. We all talk about R2O like this. In reality, if you go to the next slide, now don't click the next button quite yet. Okay, how do we do R2O? It's a little bit different. So I enlisted the help of a graphic designer, and if you go ahead and click, here is my best estimate of how we do R2O. So you'll notice a few things. There are people there. There are a lot of things in the funnel. Go ahead and go to the next slide. A few points, one more click. Okay, so first thing, top of the funnel, very full. It's so full, it's overflowing. And in fact, if you look on the left-hand side of the funnel, there's actually some grass growing in there. We shouldn't have grass growing in our R2O funnel, but some things have been sitting there a while and a little too stagnant. One more click. You'll notice that the pipe is very narrow. It's too narrow for how much stuff is at the top of the funnel. Next. You'll notice a lot of people standing around the bottom of the funnel waiting for some things to come out of the funnel. You'll notice some interesting features. One guy has 3 arms, but I won't dwell on that. But you'll see people from the Hurricane Center, forecasters who would like to see some more things coming out of the funnel. You see some researchers who would like to see their things moving faster through the funnel. And so, one more click. Ultimately, we see what I would say limited, too few outputs coming out of the funnel. All right, next slide. Or one more click. Okay, so how are we going to approach this? And this is what I want us to all discuss. I don't really know where to start with the top of the funnel. There's a lot. So one more click. So I'm going to start at the bottom of the funnel and ask you guys a question to think about. One more click. What do we actually want coming out of the funnel? We're going to have to focus. Funding constraints, resource constraints. We're going to have to focus. So what do we want coming out of the funnel? Next slide. One more click. Sorry for all the clicks. So a quick reminder. Okay, the Hurricane Center mission. We're in the business of saving lives, protecting property, enhancing the economy. Next. So in order to fulfill that mission, and you've heard some folks talk about this already, Mike mentioned it, people, end users, must take actions. They have to actually get information and then choose to do something or not do something. Next. So I'm going to argue that all that really matters, all the R2O projects we're going to talk about in the next few days, all that really matters ultimately is getting people trustworthy information so that they can make a risk-informed decision. So next slide. Let's talk just a little bit about making decisions. Every hurricane that happens, no matter how severe or consequential, people are making decisions to either act or not act. Next. Anybody who makes a decision of any kind, they do that based on two things. One is the likelihood of an outcome, probability of an outcome in their perception, and the consequences of that outcome. So they're weighing that in their head, and the consequences are really user specific. Maybe I'm late to a meeting, and so I have to hurry. That's unique to me. But the hazard likelihoods, those should be objective, and that is right in our wheelhouse. Next. So here's the long value chain of how we get there. So everybody in this room is working on one of these bolded bullet points, starting with observations, all the way through models, post-processing, human reasoning, software, data flow, product design, all the way to an end user who's making a decision based on what we give them. Next. And the way we communicate these today is through watches, warnings, probabilistic products, key messages, social media, live streams, etc. All of these are based, rooted in uncertainty. Next. So another question I'll pose for you to think about, what if we focused on this very end of the value chain, maximizing an end user's decision-making confidence? Would that change the way we design and execute R2O projects? Next. So I'm going to pose a challenge here. Think about this for the next 30 seconds while I finish, and then we're going to talk about it. Okay, next. Hypothetical question. Next week, next Monday morning, you're going to start a new R2O project of some kind with the objective of getting into operations and people using it. Next. You can go ahead and click the next three. So you make any assumption you want. This can be something you do out of hide. This can be a massive budget project. You can work individually. You can collaborate with teams, build something new, double down and leverage on things that are already going on. One more. And you can aim big or broad or narrow focused, however you want to do this. Next. The big catch here is that the success of your project will be judged solely on its ability to enable someone, an end user, to make a better decision in the face of hurricane risk. Next. So what would your project be? One more. How would you structure this project in terms of who you'd collaborate with, how you would do it, what you would want to measure? And next. And how does this project support decision-making? So very open-ended, but with that, I'm going to let y'all think for a second. I was going to stop for 5 minutes and let you really think, but just think for a couple minutes. We have limited time, so I'm not going to give you the 5-minute thinking period. We've got a lot of challenges, but I think by putting the end user who's actually making a decision at the foundation of how we start all of these projects, I think that we can make some serious progress in terms of aligning all the various groups from the physical science to the social science and integrating it all together. So with that, I'll stop. And hopefully I've given you a little bit to think about and kind of stir up a discussion for how we move forward. So thanks, everybody.
So Wara's going to moderate that discussion. I just wanted to add, first thing, there's some in the room wondering what's the name of the artist. I help you with that graphic.
The great people at OpenAI have developed an amazing tool. And in fact, the style of a lot of the art they produce is very similar. So many of you probably knew that ChatGPT produced this.
There you go. So that's his name, right? Or name, whatever, right? Anyhow, I just wanted to, one of the things, you know, what as I'm working on this, we put a spreadsheet of all the projects that are being worked on that NEC is involved with. And one, we had another over the last 2 to 3 years, so 52, I think, at least 52. Only 3 will become operational. 15 has been completed, but not yet operational. The rest are in transition or a preliminary phase. Anybody wants to guess? Or you have so many have not actually made it in front of the forecaster? Because of this. It's great to have projects out there, but the creator of people at NEC that are supposed to make that happen in reality, take what you do and put in front of the forecaster is a small group of people who are already like this, just supporting day-to-day operations. And the time they have to dedicate to R2O is like this. So as you work on your ideas, you have to go beyond just, I'm going to discuss, I have this great idea. Put it out there here and see, it's done. Look how great this tool is. But if it is not in a format that we can easily plug it into the operation, be it via the EMC, that's this, or in a format that we can easily plug it into our operational product, then it's going to be a struggle for us to bring it to operation. Let's just say it that way. It astonishes me how, when I talk, as I just informally talk to everybody out there, how everybody uses different graphics packages, right, to do their work. But very few, if anybody, uses graphical packages that we use operational. We're working in completely different worlds. Now, the advent of the cloud should have, help changing that, but there has to be a willingness to line up. And that's going to help with this. Not the final solution, the only solution. There got to be other things we got to address, but those are things that we see, that I've been brainstorming about. I don't know what the best solution, don't get me wrong, that's the idea behind this. Might be somebody here think of something we didn't think of, but if you think about this and you take it from that last slide that Wallace presented there, we might want to leave that up, let your juices flow, and it's late in the day, and we take it from there. I guess, yeah, you got it.
Okay. Yeah. So, Tim, we'll start with Tim.
I put the chat up so you can see, because there are some comments and things coming in also.
Okay.
And for those in the room, could you please announce your name before you talk? So it says we don't have video showing you, so people online know who's talking.
This is now for all talks, correct?
Correct.
This is Tim Marchak. So maybe one thing that would help, I remember in the days of HFIP gone by, there was a program where people would come and spend some time at the Hurricane Center to kind of sit side by side with the forecasters to see how they go about their job and to see what products are useful and how they use them. And that might help to trigger some creativity. And okay, I see what they're doing. I have an idea. I can assimilate it into their workflow. Is there any way of bringing that back, or is the funding too limited at this point?
Yeah, I've heard some fantastic stories about some tools that we've used for decades that originated that way. And so I think we should absolutely look into what we can do. It's tough with funding and also with the constraints of the operational process, but I think we should absolutely look into doing that. Hendrik and then Jason.
So Hendrik here. I think you have to ask yourself the question why the bottom of the funnel is so narrow. And part of that is depends a little bit on where you are in the whole value chain. If you look at the modeling part of the value chain, this goes back to something I try to point out in the first talk. The fact that our customers are so averse to any kind of risk that we have to do years of retrospective work. And so we've gotten better, not good, but better at sharing the tools and therefore being able to do it software and technically better. But if we don't deal with the risk aversion of our end customers, then we're going to be stuck with that narrow funnel for more decades. The second part of looking at that is that at risk aversion, I may be completely wrong, but from where I'm sitting, it's a lot about that is about the middle of the value chain in terms of putting a model improvement in. It does not have to be like that, I think, for further down the value chain, particularly in post-processing, in tools and things like that. And then third, if you want to be really a little bit stirring up the pot, does this just mean that we just have to go just to do social science and AI and just forget all the physical science for a while?
Lots to think about there. Yeah. Jason.
Jason Sippel, so in an ideal world where WPO, JTTI funded proposals have, large, huge amounts of money, you would have somebody on the research end partnering with somebody on the operational end and actual money going to somebody on the operational end to take that transition process and make it happen, right? In the real world, a lot of these proposals are just, a lot of these NOFOs don't have enough money to make the research happen, much less to partner up on the operational side, right? So, I know there's some opportunities out there, and I'm definitely have some in mind in the future where I would partner, for example, with EMC to take, stuff that we'd like to do at HRD and make sure that they get part of the pot too, so we could implement it. But I think that's a challenge, right? Like that in this, funding constrained environment, like this is gonna be something that winds up happening.
Yeah, very, very good point. The only thing I'll say there is that to me, it's by looking one of the points I was thinking about putting this together was if we think about the very end of that value chain, could that help us to select projects and select initiatives that kind of are lined up all the way from research to the operations, the social science and decision making,
You still need money on the end, on the operational end attached to that budget, right?
Yeah.
If you don't have it, then you're gonna have this restriction.
Yeah.
Stirring the pot further, probably the very fact that you have houseful funnel there, which means you have at an RL level 6, 7 already existing. And I'm starting to ask, what about RL? We have forgotten about RL 3, 4 at all in the hurricanes. And that's what has happened in the last 12 years I've been associated with this. Slowly we are moving towards 6, 7, 8, 9, forgetting what we should do at 4 and 5, even including social sciences. And that is, we are losing the critical balance in my opinion. And that's why you're getting to a funnel wherein it's overloaded and cannot, beyond that it cannot go. What about, and at the same time, the loss is at RL level 4 and 3. Now, universities can take it up, not at 4.
I want to make sure we have a hands up here at the San. You have your hands up. You want to? Sujin, yeah. There you go.
Because it's similar to what Gopal mentioned. By now, I think I started just to start the job just the HFIP start. So at the beginning, we have the research component in HFIP. So that means the HFIP has an independent announcement to ask the proposal from community, and these proposals really improve our science understanding, and those research gradually transition to our model development and the operational applications. So this probably, it's a low level readiness level, but in order to move further for our model development, I think we need, if possible, the funding possible, to bring back these kind of component into HFIP. That's one question. Another question is how can we right now we always use R2O, but meantime operational model need feedback to research community. So that's one of the things Hendrik mentioned, is that NSF opened that kind of door for UFS model to use in the NSF proposal. That is really challenge is for operational model. The general researcher can use that because of a lot of dependency. So we probably need to accelerate those kind of release and generalize the code so that the research community can take advantage of this operational model and contribute it back quickly.
Thanks, Eugene. So I think Stan wants to go next.
Yes, Stan Goldenberg from HRD. So many talks, so little time. Is a shame to end with that talk because we could just spend the rest of the time on that. I'm going to do quick fire for 3 different talks. And one is a great video to add to that is the video of Lucy and Ethel in the chocolate factory. Those who know that, of all the chocolate pieces sliding by very quickly and trying to grab everything, because frankly, yeah, I think this whole R2O is not a linear process. And if someone tries to control it too much, it's going to really quench the creativity. But you need somebody with some semblance of organization grabbing the right stuff out of that flow. And when I first came to HFIP the first time, I was like, why are there all these different projects and different models? Why don't we all focus on one thing? And it's the diversity of it all that produces the results. So, but I want to go back to the, the verification talk. I get really bothered when it's one trend line. And a lot of those with the years and with the decades are absolutely stepwise function, or there's a level area, then it goes down, and it kind of dilutes it by doing the trend line. I could see flat here, there, or at the end of one of them, the intensity was flat. And I would really suggest that being shown that when the only other question with the rainfall, for the rainfall people, was this an absolute record amount of rainfall in North Carolina in that area, or simply, you dump a lot of rain on a mountainous area? Was it a ridiculously large amount, or just a very bad area to dump that amount of rain? So whoever wants to answer this.
Well, I don't, is Mark, are you online from WPC?
Yes.
You want to address that question?
I was working on an operational issue, Pablo.
So, okay.
Sorry about that.
Okay, or Mike Brennan is here. He can address it. Yeah.
Wallace, do you get my?
Yeah, the rainfall rates in Western North Carolina exceeded the 1,000-year return period over a very wide area. Yeah, I mean the rainfall totals, so exceeded the 1,000-year return period. So correct. Oh, I don't know if that really matters. Does that really matter? Because the impact of rainfall is very tied to that geographic location. I don't know the answer, but I know it was an extraordinarily large area exceeding the 1,000-year return period.
Okay, we've got a question back here from Neil.
Okay, go ahead. And then Frank.
Hey, Neil Jacobs from UCAR. I wanted to point out something about the funnel that's always kind of bothered me, and that is that the top is bigger than the bottom. And it implies that more stuff goes into the top than comes out the bottom. Well, for that to happen, stuff has to be eliminated somewhere throughout the funnel. And that's a big problem because people work really, really hard on these projects, and no one wants to be told that their project doesn't have an operational end game. So sorry, we're going to have to kill it. But that's just a necessary part of the process. And I think we need to get past the fact of thinking if it's not going to have an operational end game, that this was somehow a failure. Because everything that moves down the funnel somehow contributes to advancing the knowledge. And if we celebrate these things that don't make it out of the bottom, but they're still success, I think that would incentivize directors to be more empowered to say, you know, it's okay. We're going to have to support some projects and kill some other ones, but we learned a lot on these projects. Because the thing that I struggle with is I see a lot of projects that continue to extend beyond where everyone knows we should have killed it already. And no one wants to be the bad guy and say, sorry, we need to redirect money somewhere else because we've gone as far as we can with this. But I think if we actually celebrated the things that we knew weren't going to have an operational end game for what we gained from them, it would be pretty beneficial.
Yeah, Frank Marks. So this is a struggle we've had since USWRP formed. This is nothing new. And when we worked on USWRP back in 2002 or so, we realized that only projects that were ever getting through the hurdle were ones that met NHC's requirements for putting stuff online. And so two things come to mind. One, cloud AWIPs, making it available to the research community, making it open the way we've done with the models. I mean, HFIP didn't magically make HWRF work. We had to figure out a way to make that and build the capacity so that people could actually demonstrate it. You have a hot center, but do we have the funding to support that? So another thing that comes to mind is WPO keeps funding these proposals that they say are transitioning to operations. And I'm not picking on Chandra. Sorry, Chandra. They ought to be taxing every proposal to put money at NHC or wherever the transition is supposed to happen. EMC, like we did for HFIP, we gave it to EMC. We gave it to NHC and said, this is money for you to transition this stuff into operations. We have to tax the research and put some of that money into where they have to transition it. I mean, that's just a natural thing. We have to build that capacity the way we did for the modeling to do these transitions.
A lot of them are piling up, and I have a couple of comments. Just give me, and then Henry, you go next. Give me a second.
Yes.
Just give me a second here. It's
Mark popped up online as well.
who?
Mark.
Okay.
Yeah, I just wanted to add to that
Go ahead, Mark.
comment. Yeah, I just want to add to that comment, not just transition, but operations and maintenance. You know, I think that O&M tail is what people don't, and you mentioned this, Pablo, people are maintaining things in operations constantly because nothing ever stops. And so you need to be able to find a way that there's going to be a maintenance package to, or a maintenance program for anything that gets transitioned to operations.
Thanks, Mark, and I'm going to just comment, then Henry, then Dave. I just wanted to say you got exactly what I've been struggling for the last year and a half. Is when you guys are working on these proposals, you have to be working with thinking about the deliverable that is in a format ready for us to take in, that it doesn't involve significant effort on our part to put in front of the forecaster, because I'm telling you, we don't have the bandwidth. Okay, it's just after a year and a half, I just realized it's time for me to stop getting frustrated and just openly talk about this with the R2O community, because it's a real issue. And then, of course, thanks, Mark, for adding that comment about the OM tail, because that is really important. One other thing I wanted to address, Neil and Stan, is you're right on. My intent here is not to stifle innovation at all. But I also see this trend internally in the agency that goes back to your time, but it's only been increasingly ever since then, is a trend to better justify what we're spending money on And what is the metric of, right? If we cannot show something came out of it that's benefiting the operational community directly or our partner community, look at the comments from Dave Jones in the chat, it's going to be more and more difficult for us to justify getting funding for it. It's only getting tighter. The pipeline is we begin to see internally what I think is more things getting tighter. Okay, we're going to have to have a very strong argument to keep funding certain ventures. But if I have my way, absolutely, and there with you, we need to. The science not going to move forward if we don't give room and latitude for people to think out of the box and find out. Don't think about it at this point in time, right? That's what science work. Let it lead us wherever it goes. But at the same time, we need to be thinking of the operational needs and make sure that those are addressed as an outcome from all of these research projects. And Frank, what you said is exactly what I was thinking. But let's go to Henry and then Dave from NAC. Go ahead.
Yeah, so Hendrik here. This is not an excuse, but this is a reality too, is that we are hit pretty badly by acquisition law in the sense that it is much to get something to readiness level 8 than to get it from 8 to 9, because you suddenly go over funding boundaries and over funding authority boundaries. And so since somebody called out Chandra, thank you for thank you for WPO realizing that and doing these internal fundings now, especially for 8 to 9. And so that is something that we need to do more. We need to get more. So whether you tax it off the top or whether you realize that some of that funding needs to go there, that makes I think an enormous difference. So thank you, Chandra.
So let's try to answer that.
Yeah, in fact, that's what exactly I was going to say, but thank you for helping me. But when JTTI was created, initially a lot of people wanted to fund, this is OIR program, should be funding OIR projects. I'm the one who decided to take all the way to RL8. I'm the one who came up with the internal competition and make the NWS people collaborators on this project. So I think JTT, sorry, I'm trying to hold my breath. So there is a competition coming, just, it's going to be announced anytime soon. And then the whole point of it is a lot of collaboration from the NWS folks on this project, projects, okay? So, but again, I can only take it fund all the way to 8. JTTA cannot be funding projects to RL9 because there is NWS issue. So NWS has to address that. Okay, thank you.
Dave Zielinski, NHC. So I'm the team lead of the skinny part of that funnel and the pool. It's the same group that does both. There's 6 of us, and that's the whole team. So there's 2 things I want to point out. Mark touched on one, and this is the only thing other than the 3 arms that I take exception to Wallace's graphic, and that is it implies that the pool isn't full yet, but it is. For our current staffing, it is. So anything that goes into the pool is going to displace something. And kind of getting at what Neil implied, the bar, as your pool gets full of more and more things that have met the bar to maybe displace something else, the bar gets higher and higher and higher and higher. And pretty soon you get to a point where it's almost impossible to displace what you have. So maybe you're improving what you have, but there's not a whole lot of new things coming through because you can't afford to lose anything else. The other thing I wanted to point out is we haven't talked about the fact that that funnel is shared with other things. For instance, we will get mandates, whether it's for IT security purposes or because the Weather Service wants to stop paying for a type of software, or because we have to retire NAWIPS because it was developed by NASA in the 1980s and doesn't meet modern standards for whatever it is that we need to do to maintain it. When you're talking about a team of 6, I would say in the last 4 years,
we've dedicated on average something about a third of our time to just trying to retire Nmap. And we're still not done. And that means that we took a whole third of that funnel right off the top. We didn't get resources to do that. And it's not that there isn't teams being funded to work on it, but at NHC specifically, we didn't get another person to come in and help migrate us. We just took it off and we keep going. So, you know, when Pablo, I think you mentioned 3 out of 15 projects out of the last 10 years or something in the JHT hot umbrella have transitioned. But when you include the mandates, which are their own form of R2O, the success rate of those is near 100%. I don't know. Wallace and I were looking at the numbers. It was something like 8 out of 8 or 7 out of 8 or something that we did in that same time frame. So it wasn't that things weren't getting through the funnel. It was that we put a full stop on R2O from this community to allow things that were mandated by NWS leadership for good reasons in many cases. But that's kind of the reality, that there is a pecking order, that the funnel isn't equal. So yeah, we just got to keep in mind the pool is full. So anything that comes in has to displace. And as we have these mandates, and we're going to continue, I mean, our migrations are going to go on for another couple of years at best. And then we're going to start migrating to the cloud. So we're going to start the whole thing over again. So, I mean, it could well be 5+ years before we're not dedicating a couple FTEs a year to technology migrations. All right, lots to unpack. So Wayne's got a question, and then Gus.
My name is Wayne McKenzie. I'm from the Weather Program Office. And, you know, it's funny, just sort of listening to all this conversations reminds me of when I was at NESDIS. And so I won't date myself, but I was at NESDIS a little, you know, we'll say over a decade ago. And there was this dichotomy. It was operations and research. Research threw things over this imaginary fence, and operations made it happen, right? But then as resources tightened up, what happened, right? Things got lobbed over the fence, but ops couldn't do anything with it. And this is exactly what I'm hearing, right? And I think now at NESDIS, what they've done is, and it may be a playbook that we want to examine, right? I would encourage folks to take a look at. What they've done is they've actually built out the capacity to do that transition activity. They have a group now that its only job is to take the research, operationalize it, so that way it can just plug right into the operational systems. And in doing that, right, you help with the issue of that we've been talking about, which is resource constrained folks in ops. They can't do everything. They have unfunded mandates that come down they have to handle. They can still do those things. And this team's job is to handle those updates and doing really a lot of software engineering that, frankly, I don't know, when I was a scientist, I didn't want to do, right? I wrote terrible code. And so, you know, let the software engineers take the terrible code and make it good. They know what all the software standards are, and they handle that. Now, the same problem still applies, right? The funnel may get a little bigger, but it's still going to be a resource-constrained issue. And so this gets to my second point. I left NOAA about 6 years ago to go private to learn how to do Agile. And, you know, one of the things that I came back, so maybe I'm nuts, but one of the things in doing that was I was able to sort of see the other side of the coin, which is, you know, how do you do a DevOps approach? And I'm not saying, and I'm still not convinced in my head that a true DevOps approach would work for us at NOAA, just given, you know, we have scientists, right, and then engineers, and a lot of times the language barrier between those two is pretty large. But, you know, one of the things, though, the key tenets of Agile that I think could be useful is think about defining a problem that we can build a consensus around to build solutions to that problem, right? Because I see a lot of solutions, great, right? And this gets back to, and this is a balance, by the way, gets back to the comment about we don't want to stifle innovation. But at the end of the day, right, we need to work to solve problems, right? And so if we spend the time to define the problem so that way solutions can be built to that problem, it may help a little bit with the amount of stuff that's on the top of the funnel. So just wanted to make that comment.
Gus Alaka, HRD. I'll speak from the research side of things. This is why the long game is really important in terms of strategy and funding. Because if you get too close to higher readiness levels and lose sight of those mid to lower readiness levels and all of the great innovations that go into that, we run the risk of getting into a scenario like Neil said, where there's all these great transitions and Dave was alluding to it too, that we just can't get into operations, right? And, you know, just one example, again, this is just something that I'm close to, but this basin scale project that's now in the HAFS world, I mean, this started as something in the HWRF world years and years ago. And again, because of strategic support from Frank and others along the way in HFIP, we've been able to keep that project alive and show value and show that it is something that should eventually be transitioned into operations. But we're also hedging our bet by, as a research organization, making sure we're using that tool as best as we can to further our understanding and make sure we're in a position that when operations is ready to take that and the funding opportunities are there to help it get there, that we're able to jump on. And it's definitely not an easy thing to answer, but I think what I'm really trying to say is if we get too close to the higher readiness levels, we're going to run into these issues where all of this great work really runs into the strategic problem about how do you actually get it into operations and what's next down the pipeline, right? And so when I gave my talk, I mean, one of the things I said is, you know, we're having this two-pronged approach, right? What I meant by that is we're building a system out that we can do our research, but we have direct bridge and connections over to operations. So as NHC, or we'll just say the Weather Service has the capacity to take components or pieces of it, we can work with them on that. And until they do that, we can continue doing our science and making sure we further the understanding and build these components more robustly so that when and if the time comes, we're ready to do that. And again, there's no easy answer here, but that's strategically where I think we need to get to.
Yeah. Question back here from Kate. One real quick comment. I've heard a common theme here. So if you think about that graphic I showed with the pool and the funnel and whatever, we're not good at keeping the funnel running. Like we're not good at draining the pool. We're not good at shoving things down the tube. We're not good at getting rid of things that are clogging it up. We're not good at oftentimes we're not good at making these hard decisions about, you know, what do we want to take away that we've offered for 3 decades, that kind of thing. So we need to work on unclogging it. All right, Kate.
And yeah, this relates back into what we've heard from several people, including, you know, Gus just speaking up now, is that entire pipeline. Because yeah, it's like you can only do, you know, just the higher level RLs for so long. Get your low hanging fruit in that's just been sitting around for ages. If you don't have the research and development components to go along with it. But at the other end of it, you know, the developers, you know, they develop something and they're tossing it over to operations. There's no support for the developers to actually help if they run into problems or anything like that once it's tossed over because of funding restraints and other issues there. But also when you've got a clogged pipeline or a clogged funnel, like you were saying, 3 out of 15 projects, right? I mean, we've had projects that have been stalled for over a decade at this point. And the developers have kept it running out of hide for that decade, you know, waiting for a transition. And then things just build up on the research side, which also impinges on their pools to tackle new things and big things and get those higher improvements that will be needed going down the way because they're so busy trying to just, you know, maintain things that haven't made the gap, you know, jump that gap yet.
Hendrik. Yeah, Hendrik here. I want to react to what Wayne was saying because, yeah, agile is a buzzword and it is an important thing to do. On the software side of things, we've been slowly but surely moving to agile. There are a whole bunch of modeling systems that really are agile approach. What Epic is doing with the releases, that's a formal agile approach. So we made progress with that. The fact that we do have operations and research working more and more with the same software we can show that unlike 2000, when we had the National Academy of Science saying, do these things to bridge that valley of death, that didn't do anything. But you can make the case that with HFIP and HFIP, we do have 2 or 3 or even more, 4 or so times more innovations that went in than went in before that. The problem is not whether we know what agile is. The problem is that we have these end users that do not want any risk and force us to do heavy duty waterfall at the backside. And so this comes back in that sense to needing to be able to work with our end users on how to deal with risk. And that is a completely different discussion than the discussion of whether you can do agile for software. So I completely agree with you and also disagree a little bit with you on the same thing. On the other part, and I may be wrong, I may be a little bit preoccupied by the fact that I like modeling. I see a lot of the problems with the innovations coming in with that forced waterfall at the end in modeling. Well, if we say that modeling is foundational to what we're doing in the weather service, we need to probably put a little bit more. We may need to put a little bit more resources into that. We use less than 5% of our manpower in the weather service for modeling. Actually, less than 2% if you look at it. And not only that, due to the way that EMC has been funded over the years, EMC and NCO are the 2 places that have a lot of contractors and very little federal stuff. And so internal choices over what we do with budget, of course, that needs to, by law, be decided internal of the government. But having said that, I do like what Ken Graham is going. So do you like what the weather service gives you? You know what it costs you as a public? $4 per person per year. Do you think you get value for your money? And so I like what Ken Graham is trying to do in that sense to make the case of what an incredible deal you get if you want something from the weather service. I hope that will translate into actually funding, particularly for being able to do transition to everything that we do a lot faster.
That's 10 minutes.
Yeah, so I just wanted to add a little bit more to what Hendrik said. This is Vijay from EMC. Having lived through several implementations, several R2O projects, one thing that I noticed is the pain point still lies with the heterogeneity of our computing systems. And a lot of our time is spent just re-engineering our softwares, retesting, make sure no bugs, no degradation because of changing the platform that we're using, or the research is always good, but not always at the same resolution as the operations. So you have to potentially recreate the same research in an operational environment, which is not easily accessible by our researchers. We have only a very few people who have the luxury of getting onto WCOS. And there is no WCOS equivalent environment anywhere in the RDHPC world. Things may change in the future, but in the last 20 years that I've been with NWS, it is still the same process. We have made significant progress in the CI/CD for the software part of it. Everybody uses the same code base, no question. It started with H4, now UFS. Open source, open development, very fast way of changing the software, but the hardware is not the same. The capability to run the tests that are required to prove the value before it meets the requirements for the readiness levels, it still lies with a very few handful of people, and that needs to change as well.
Hello, this is Suresh Mani from Office of Code Survey. I'm kind of an outsider here, but I feel that last step where there's user involved, there's that risk that want to avoid, or the user wants to avoid. it helps if that requirement is codified. Basically, the good testing of that kind of requirement would help really with kind of making the whole workflow go through that whole funnel kind of be smooth, so that there are no blocks. For example, every group that, let's say you want to change, specifically we're working with NHC right now, trying to come up with the so-called next generation for PCERT. So we have to go from scratch and find out, okay, what are the requirements that needs to be met? First the technical, then the infrastructure and all of that. What if all of that can be codified by a specific group, whether it's within the research group or a separate group like EPIC, such that for every kind of iteration, we shouldn't start from scratch. So basically, the codifying of the tests, I think, is important. And it also goes back to making everything agile. So that is really missing. If we don't have that, we don't have really agile process.
One quick comment on the agile. Wayne mentioned DevOps. Like, I think the reason these are being mentioned is because they treat the research and the operations as one unified system and not one that hands something to the other one necessarily. So I think those are good things that we need to explore further. All right, do we have any other, let's see.
We have Dave Jones online.
Okay, sorry, we've been poor at monitoring the chat here.
Yeah, we have
I've been monitoring, don't worry.
Dave Jones, raise his hand.
Okay.
Dave, you want to go ahead?
Sure. Hi, Pablo. It's good to hear your voice. I just have a couple of quick observations. One is that, gosh, it was probably now 12 years ago. We had a meeting, and Louis Uccellini was in there along with the chief operating officer of NOAA, of the Weather Service, and others. And one of the things that came up at that time was, those of you who know Louis, he slammed his fist down on the conference table and said, why do we make so many products within NOAA, yet users know about 2% of them? And, there are a lot of products that are out there and available. And unfortunately, users aren't accessing them, and they don't know how to use them if they did find them. And so I think it really comes down to a priority. I mean, the Hurricane Center is doing a great job at coming up with, you might think they're little tiny incremental advances, but, there are significant ones that the public and users and decision makers can understand. And, I think that one thing that might help with getting, crossing that valley of death, and I've been there for 15 years, is being able to take feedback and input from outside of NOAA and bringing that inside to talk about how products might evolve to satisfy those requirements that actual users have. And Hendrik, I would agree with you to a certain extent about, you have these users that want zero risk. It sounds like you're talking to the insurance and reinsurance industry, but don't let them drive everything that the Weather Service does with regard to modeling. There are a lot of users out there who don't understand basics. And if we could just pull some of the data out of NOAA and the Weather Service Hurricane Center and apply it into these different user groups, you would have a rapidly growing constituency of supporters, which I think is going to be critical in the future to make sure people understand what's happening. And to accelerate research to operations, leveraging that SBIR program, which I've been on my soapbox for a decade about that, but many people don't understand the significance of SBIR. And when another agency invests over $1 million in a product and it gets to some place that could be used by other agencies, it's something that should be leveraged to get more products out to NOAA. And I know there are some good ones that are out there, but I think that, that's it. I'll just put little comments in the chat, but I really appreciate you guys opening this to online participation too. Thanks.
Thanks, Dave. I think we You have, Selena, you were gonna say something or?
We can give Zorana the last word.
Yeah.
We were gonna, I think it's about time to wrap up. People are starting to get hungry. But Zorana, you get the last word.
Talking about hunger, I was thinking of that funnel and how some things are stale in there. So maybe we don't want to taste it. But the thing is, if something's sitting for 10 years, wouldn't it be better that we start and learning from it, from the conclusions of those projects and building something new that can go through the funnel? I'll talk from the perspective that I understand, and those are aircraft instruments. We are going to future with the new aircraft, but we are pushed to transition the old instruments into that future. Why are we not just learning from what is good about these instruments and build something new? We are pushed to operationalize all these products right from research instruments, but should they really be in operations? Operations should just get a taste of it, but we should give them something better that combines all the lessons we learned. That way, I think we can reduce what's in the funnel and get something new.
Well, with those words of wisdom, we wrap up. Keep the conversation going through the week. You know, I really want to keep this channel open.
I want to thank everybody that presented today. And we will start tomorrow morning at 8:30. Our first session tomorrow will be chaired by Vijay and is on perspectives and updates from operational centers across the globe. Thank you and have a great night. Oh yeah, for those of you that are not staying at the hotel,